scientists explore the microscopic universe, they find it's governed by rules that are often incomprehensible to those of us in the normal world. At the smallest scales imaginable, human observation often seems to decide what happens.
It seems like the behavior of quantum mechanical stuff is different when we're looking at it than when we're not looking at it.
This profound conclusion comes from performing the double hole experiment. Scientists first conducted this experiment a century ago, firing photons of light through a metal plate with two slits. The light that went through the holes hit a screen behind the plate.
I'm going to demonstrate the results of this amazing experiment with a bunch of baseballs and a barrier that we've set up which has two holes in it. Now, normally in the everyday world, if I throw baseballs through one hole or the other, they'll form a predictable pattern on a screen that we've set up behind home plate. They'll be in one place or the other. Now, let's make that pattern with a whole bunch of baseballs. I'm going to use this pitching machine. Here's the first one. Let's see what happens. Now you see, the balls landed on the screen in two bunches, pretty much along a direct line from each of the two holes. That's natural. That's what we expect. But when we descend into the microscopic universe and use electrons, which are 10 trillion times smaller than baseballs, we get a very different, odd result when we perform this experiment. A pattern that you would expect if these were waves going through both holes at the same time and interfering with themselves. Well, we usually think of electrons as being particles. So how can they exhibit wave-like properties?
These test results were confounding. The electron was a particle before it was fired at the screen, yet it formed a pattern on the screen, as if this single electron had gone through both holes at the same time. Does a microscopic particle spontaneously clone itself in midair? After years of study, scientists still don't know exactly what's happening.
Probably the most magical thing is that in quantum physics, an object can be in more than one place at the same time.
To try to grasp this amazing experimental result, scientists decided to observe how individual electrons behaved when they went through the double slit. How exactly could a particle go through both holes at the same time?
They didn't just look at where they landed on the screen back there. They also watched the behavior of the particles as they went through the holes. And then they saw something amazing. When scientists were watching the holes, the electrons behaved like particles, forming the baseball-like pattern on the screen back there. But when the scientists weren't watching, then the electrons behaved like waves. They formed a pattern that looked like the interference pattern produced by waves on a screen. That's really strange. What you see depends on whether you're watching or not.
Observation seems to change the nature of subatomic particles.
Mysteriously, when we're not looking, things are waves. When we are looking, they look like particles. So even an electron, which seems to us like a particle, has wave-like properties when we're not looking at it.
How could our decision about whether to observe something change how that something acts?
The short answer is we don't know. This is the fundamental mystery of quantum mechanics, the reason why quantum mechanics is different.
This is something we scientists have argued passionately about now for almost 100 years, and there's still no consensus.
When they were first released a century ago, these test results were enough to unsettle the brightest mind in science.
Einstein said, I don't believe in quantum physics because I believe the moon is there even when I'm not looking at it. Einstein was, of course, referring to the implications of the theory that the moon really isn't anywhere until it's observed.
However, the double hole experiment's mind-boggling conclusions don't end there. In recent years, technology has allowed scientists to perform a fascinating variation of the test. Its results call into question our perception of time itself.
Electrons are being fired toward a barrier with two holes in it. But the scientists can delay their decision about whether to observe the electrons until after they've passed through the holes, but before they hit the screen.
At that moment, the electrons, in essence, become particles, and seemingly always were particles from the time they left the electron gun.
So it's as though they went back in time to before they went through the holes and decided to go through one or the other, not through both as they would have had they been behaving like waves. That's really crazy.
The rules that govern this subatomic world hint at a universe that's just as mysterious as science fiction. In fact, quantum physics may suggest that reality is simply a figment of our imagination.